Hi everybody. In this class what we're going to do is we're going to be using QuickTime in order to be able to record a lecture. And this way you don't have to go for an entire week without a lecture. And so what I'd like to do is I'd like to introduce you to the basic idea of the file system. Files in Java are handled by a java.io.api. File is considered as data input, generally a sequence of unformatted bits. These bits are used for input and for output. You typically put them on a hard drive. Hard drives run faster than RAM. Typically hard drives run in milliseconds, which is 1 times 10 to the minus 3 seconds, whereas RAM is in nanoseconds, which is 1 times 10 to the minus 9 seconds. That 6-order magnitude difference gives you RAM based files as 1,000,000 times faster than disk files. This gives you a cost-performance trade-off because RAM is often much more expensive than disk space. On the other hand, because of its inexpensive nature, file systems that run on the disk can be quite a bit faster. There's a class in the Java I/O package called the file class, and it's responsible for making sure files exist, making sure files can be read, making sure files can be written, allowing you to manipulate directories, allowing you to list files in the directories, and allow you to traverse the entire file system. The file class is the centerpiece of the entire file system manipulation facility in the Java I/O package. Different operating systems represent file names differently. Typically what happens with a directory is you use some sort of a file separator. So /home/lion/foo.java is a Unix style representation, whereas C:\\, that's a Windows style representation. And on a Mac they use colons. So 3 different operating systems use 3 different file separators. What a mess. To find out what file separator you're using presently as a Java programmer, assuming you don't know what operating system you're on, you can go to the system.get property and call file separator. And that will return a string which enables you to get access to the file separator. On Windows it'll be a \. So this is typical. If you're formulating a path, you'd like to have file separators in between the folder names, but then if you want a list of fully qualified directories, you need what's called a path separator. Now the path separator is different from the file separator, and in this case it's a semicolon, and that happens to be the Windows standard. And here you can see a whole list of different sorts of file separators with different paths. And this gives the command line interpreter in DOS the ability to search all these directories in order to find commands. Using this path separator, you can then proceed to go about getting information about how you're going to separate the different fully qualified directory names when you're listing out paths. In the API that I've developed, I have a thing called Feudals. It's a package that I've written myself, and in that package I have a class called Feudal, and in that class I have a static method called getDirFile, and what that does is it gets a directory file instance which enables you to proceed to read files. So we call this the getReadDirFile invocation, right? And then you pass in a prompt and it says select a file. That'll allow you to get a directory for read. And you can prompt the user for a file. You can call getReadFile, also in the Feudal package. And then you can proceed to do manipulations. Here's the file, and now you can select the file for read. So getReadDirFile takes a prompt, and if you want to, you can go to the file instance and call getParentFile, which will get you the super directory. With that parent file, you can list all the files in the subdirectory. So here's what it'll look like if you use the directory selector, and if you're in IntelliJ, and you're wanting to have access to the Futil package, the Futil class in the Futils package, you can proceed to open up Futil, scroll to the bottom. You can see where I set swing to be true, and then I can select a file for read. So this allows me to change whether I use swing or the AWT. Now you've got this file instance, what can you do? Well, we can print it. Calling sout, Control-J, enter, prints out the system.out.print line, and that converts the file to a string. So now when you select the file, you can see a fully qualified path name which leads directly to the class of interest, which is just what you're looking for. So then the question becomes, okay, what does this getRead file do? Good. Glad you asked. Well, what it does is it determines if my little file bean is in swing or not. And what we'll do here is we'll skip over the part where we talk about how to read files, whether they're in AWT or swing. This business about graphic user interface involves more API than I'm prepared to discuss right now. Back to the lecture. So here we have a prompt coming in from select a file, which allows us to get a file for read. And then what we can do is we can make use of polymorphism to implement what's called a file name filter. The file name filter will accept a file and return true or false if the file name filter is satisfied. And you can define how complicated the file name filter will be at will. So for example, if I want all the Java files or all the doc files or all the text files, I could write an accept method that accepts all of them. File name filters are excellent if you want to list all the files in a directory and then make sure they satisfy some criteria. I have a special class called the ls class, which works like a Unix command. The ls class is a class which you can find in Futils. Here it is. This gets you all the directory files. These are files which contain other files. Let's see if we can try and use some of this good stuff here. So here's a new instance of a file which looks for the root directory. But I think what I'll do is I'll start with the directory in my Unix system. So let's figure out where I'm at. pwd prints out the actual path name, my attach point, and then what we'll do is we'll go into make a file that shows all the user documents. And now what we can do here is see if we can run our program. Put in a command ls and it lists all the files. Isn't that cool? cd eagle ls, no files. cd ... ls, and we're back to the top. cd tbird ls, and you can see more files in the subdirectory. cd ... ls, now you're back to the top. So using this command structure, I should be able to make a directory. Make dir foo ls, and there's foo, cd foo ls, and there's no files in foo. So now I can envision how the ls command can be used to create a standard DOS-like style input system for Java. Isn't that fun? Yes, yes. Very fun. Very fun. So how does it work? Well, we start with a root directory, and then we proceed to call in.getString, which gives us a graphic user interface that prompts the user for a series of commands. If the command equals ls, it lists the files using f.list. If the command starts with make dir, it makes a directory. In the file system, we can proceed to get instances of the fully qualified directory name. We can determine if something is a directory, and then we can proceed to call make dir, and it will actually make the directory, which is pretty cool. cd, we can use the cd ... to get the parent directory. That goes to the superior directory, or if we find the directory exists already, we can go to the subdirectory. And at the end of the day, if you want, you can put in a quit command that'll get you out of the system. Let's see if that works. Command quit. Yep, works good. So there you have it. You can create your own little command line interpreter, your own little DOS computer, all within Java using little more than the file command. Sweet, right? Yes, very sweet, Professor Lang. Oh, thank you. This is the problem when you don't have a class. Well, what are you going to do? So now I've got a mechanism where I can list all the files in a directory or even in its subdirectory. And if I want to list all the files in all the subdirectories, I have to keep in mind that I've got a tree system. And that tree system is really going to give me a directed acyclic graph, which will allow me to traverse an entire folder plus all of its subfolders and all of its files and all of its subfolders. And the reason you'd want to do that is maybe you'd like to compile something or print all the files or delete all the files. Don't do that. Or build a catalog of files. And you can use a mechanism for creating a file name filter and then create the so-called dir list, where dir list will give you a list of files in the present directory and all the subdirectories. So let's go into the dir lister. And here's a special dir lister which gets you the big file list and then proceeds to print it. So we'll run the dir list main, and what we'll do is select a root directory, and here are all the boot examples, book examples. And I'll select them, choose them, and now this is every single file in that directory plus all of its subdirectories. And that's pretty cool. How many files do you suppose there are? Well, you don't have to count them yourself, right? Because you've got an array. So if you wanted to find out how many there are, oops, SOUT, Control-J, Enter, there are plus fa.list length files. Now when you run it, it found 996 files. Fun, right? Now what can you do? Well, you could delete all those files, or you could convert them all into something else. What that might be, I do not know. What do you think of that? Good, right? Will it work for any directory? Yeah, sure, you betcha. So suppose we go over here to the source directory. So here's the source directory for the entire distribution, and what do we see? 6,049 files with fully qualified names for each file. So what do you think of that? Pretty good, right? The Java I/O package. So how do I do it? Well, if you look at the dir list class, which is in package utils, what you see is some GUI Not a lot, but some, because you want to prompt the user for a directory name. And then you have a mechanism in place that allows you to simply use the file API. And so here at the end of the day, I do a sort. I can print the stats. Now, what would be involved with calling print stats, do you think? Let's do that. I think that sounds like fun. So, dir list dl equals new dir list of, and it says here it's going to take a start file, feudal dot, oh, looks like we've already got that. Just a minute. Here's our dir list. We can go in here like this, dl dot print stats. Let's do that. We'll print the stats. And hit run. It says so 6,049 files with a total of hundreds, thousands, 32 megabytes. And that's just source code. Pretty slick, right? A powerful system. So the wild filter, which is a implementation of a file name filter, FNF, is passed into the dir lister. That enables you to get all the files that end with a suffix, begin with a prefix, and contain some string called a midfix. And then you can proceed to get all the files that you like. So let's take a look at the wild filter. And you can see now it's got a constructor that lets you take a suffix, a constructor that lets you take an array of suffixes that you can look at, a constructor that gives you a prefix or a suffix, and a constructor that gives you a prefix, a midfix, and a suffix. And this gives you the Control Q gives you the Java doc on the wild filter. So that wild filter can be used directly when you call in the dir lister. And that's my little introduction on chapter 14. Hope you liked it. Thank you.